So the specific objective of the project are to help raise the research profile of the leading institution, our university, as well as the research profile of staff and young scholars from all three widening countries, which are participating on this project. And the third specific objective is to create a hub of excellence in additive manufacturing in this part of Europe by engaging with the scientific community, industry, and society of the three different countries involved in SIRAMM project. So we already did this. We implement a research quality assessment plan for our university based on the indicators, research indicators, which were put it on the project. Basically, this kind of project did not finance research and did not finance acquisition of equipment. It's only for transferring of knowledge and these activities. We have to do some regular stuff. I will show you a map of the exchanges. Unfortunately, we were not able to do it because of the pandemic crisis, but we hope to start this year to have all these activities done. What we also plan is to establish a course in additive manufacturing for our postgraduate students. This was planned for the last year of the project. However, because last year we have the accreditation of our master program, we insert this in order to be advised by our quality assurance. And this course starts earlier, so starts from this semester and will continue in the following years. A similar approach will be applied at University of Belgrade. So they plan to introduce an additive manufacturing course to postgraduate students. So what we want to spread the acquired knowledge among different stakeholders. We invite in the project, and we have the support since we apply for the project, of Continental company from Romania. We have also Vitesco company with us. We will have a presentation in the afternoon from the let's say company part, industry part of the stakeholders. We have also different communication and dissemination activities to be done. We have a Facebook page, we have a Twitter page, we have a LinkedIn account and the ResearchGate account. So anyway, for such a project, we need to start from some scientific ideas, and we start from the fact that additive manufacturing technology is very attractive nowadays, and many industries try to use it in order to speed up their production process. So the advantage is that you can obtain very complex shapes and parts with quite high precision and characteristics. The good thing is that you can apply this technique with different manufacturing technologies, but you can apply for polymers, and the most used is PLA, polylactic acid, but also you can use ABS, polyamide, but also additive manufacturing is used for metals, steels, titanium alloys, and also for ceramics like alumina, zirconia. So the advantage is that you have a broad range of materials which can be used in additive manufacturing, and you can print very complex shapes. You have 90% of saving of material comparing with the classical manufacturing technologies, and the reduction of the time of design with 85%. However, there are some challenges because the additive manufacturing process differs from traditional processing. Not all the material in additive manufacturing, it's melted and homogenized at the same time. So we have layers by layers deposited, and this can produce on one way anisotropic properties of the components that are obtained, also residual stresses and some structural and fatigue problems. So our projects address this, the integrity and reliability of such materials. So also we have not an homogeneous and complete field. Even we use 100% in field, you can obtain a shape which is not completely filled. So some drawbacks of these techniques: low quality surface of additive manufacturing, and basically in polymeric materials, but also for metallic parts, it's quite high porosity, quite high scatter in results if you try to test them or to measure the dimensions of the obtained parts, dispersion of data, variability of lifetimes. In some cases, the durability or the fatigue strength of the components obtained by additive manufacturing is very low comparing with the other techniques, up to 10–20%. And also what we want to address is to look on the notch and size effect on this additive manufacturing components. And here we will have a transfer of knowledge from Norway, where Professor Berto is one of the world experts in notch and size effect, using different approaches like strain energy density, and probably he will show us Thursday morning these approaches. So for this project we have 5 work packages. First one is coordinated by NTNU in Trondheim, this process classification and mechanical characterization. We have the modeling part, multi-scale modeling and material optimization, the work package DOI, coordinated by University of Parma. And the others, which are the postgraduate and early stage researcher specific training, communication, dissemination and exploitation, and project management and scientific strategy development, which are coordinated by University Polytechnica, by the coordinator of the project. So each year we plan different activities. So we have seminar for students, we have staff exchange, workshops, this first, which is a winter school now, PhD exchange, and these are splitted on different work packages. So you can see here a map of the staff exchange from Romania. Each year we need to have 2 researchers going to our West part partners. From each country we define mobility for the staff exchange, and also for PhD exchange. We have 2 PhDs to have stages at least 3 months in Italy and Norway in each of the 3 years of the project. We need to organize seminars with students, seminars for companies. The this winter school, the next one will be in Czech Republic, and the last one in the 3rd year will be in Serbia. We'll have workshops, and I will invite you to join this workshop. The first workshop will be at the end of February, organized by us, probably in the same way, in a hybrid manner. We will have in the 2nd year an East European conference on additive manufacturing, and at the end of the project, we need to organize here in Timisoara an international conference. So these are the mobility actions. We also budgeted in the project participation on 3 conferences, 2 staffs from East European partners, from UPT, from Belgrade and IPM, and 3 for 1 per year, 1 staff from our West partners from Parma and NTNU. We need to publish some open access publications. we have budgeted this, and I told you already this master students course, which starts this semester, theory and application of additive manufacturing materials. I will want to go a little bit to see the scientific part that we already did. So we look on the effect of manufacturing parameters on tensile and on fracture toughness properties of polymeric materials. I will show you only some brief results on what we get already, but probably more results we will present on the workshop. So we use different printers from our university, and some specimens were manufactured on Trondheim when one of my master students was there. We use 100% in fill and rectilinear plus minus 45 degrees in fill with 100% density with different layer thicknesses from 0.15 millimeters to 0.4 millimeters. We printed the specimens in two planes, horizontal and vertical, and we consider three different specimens orientation. Here are the young modulus and the tensile strength. What we see, the difference between the two planes are not so big, but anyway, we get higher stiffness and low tensile strength when the specimens are printed vertically. The lower properties were obtained for 45-degree orientation, and also on the vertical direction, we have quite a high scatter on vertical direction. For the fracture toughness test, we determine mode 1 and mode 2 fracture toughness using single edge notch bend specimens loaded symmetrically in 4-point bending for mode 1 and asymmetric 4-point bending for mode 2. Also, we look on the specimen orientation. You can see here the specimens coming from the printer and the fracture toughness values. All the mode 1 fracture toughness values are higher than the mode 2. As numbers, for mode 2 fracture toughness, we have 2.78, the lower fracture toughness obtained for the 45-degree direction, and the higher fracture toughness for the mode 1 is 4.68, obtained for 0-degree orientation. We also want to see what's happened if we manufacture the notch or we cut the notch by milling. So, and the results are here also for the two printers. So higher fracture toughness values, and the higher fracture toughness value was 6.5 megapascal square meter. They were obtained from 3D platform with a layer thickness of 0.4, and lower values were obtained on Prusa printer, and this was around 4 megapascal square meter. Also for mode 2, the values are lower, around 3.58 is the highest mode 2 fracture toughness, obtained also from the 3D platform printer. And also all the results, all the fracture toughness with manufactured or directly 3D printed notch have higher value comparing with those which were, the notches were manufactured. We also, because I need to finish, we also publish some papers. All the papers are on the website of the project I mentioned. All are open access. We have already 5 journal papers, with 2 review papers on additive manufacturing, and we have 3 conference papers. All you can find all these results. What we did also, we organized some special sessions during conferences, during the Mediterranean Fracture Mechanics Conference in Athens last year. And on the first virtual European conference on fracture, we have, together with TC15, a special session dedicated to additive manufacturing. What will be next? So we have the workshop. The workshop will be 25-26 February, organized also hybrid. We extend the registration and submission of abstracts up to 15 February. The participation, the same like in this winter school, is free. We plan to have the preliminary program just before to start in 23 February, and the submission of final papers for the material design and processing communication. It's an open access journal published by Wiley. It's a new journal published by Wiley, and the editor-in-chief is Professor Berto. Normally after the normal reviewing process. So I encourage you, we want to organize here some dedicated PhD sessions. So please come, you will have more time here for present your work, the PhDs, and will be also at the end, you will have published papers in a good journal. Next events will be the East European Conference on Additive Manufacturing in Belgrade, and final international conference in the last year of the project, probably will be at the end of 2022 or beginning of 2023, if we want to take advantage that in 2023, Timisoara will be the European capital of culture. So that's all from me now. I would like to acknowledge the support from the European Commission through this SIRAMM project, and also the support of European Structural Integrity Society. From these meetings comes the idea of this project, and we have their support in advertising our events and in using the web TV, the new service of ESIS, the web TV, to put our lectures and all the other things that we can produce during the project. So thank you very much for your attention.